Hi everybody! Today we will take a look at how to measure the melting point range of a solid. The melting point is the temperature at which the solid and liquid phases of a pure substance coexist at a pressure of 1 atmosphere. In practice, a solid usually melts over a range of temperatures rather than at a specific temperature point. Therefore, it is better to report the melting point as a range. A melting point range consists of two temperature values. The lower temperature is recorded at which the substance just begins to melt, and the higher temperature is recorded at which the substance completely liquefies. The melting point of a solid is used by organic chemists to identify a compound and also to ascertain its purity. Because the presence of impurities lowers the melting point can be a good indicator of purity, where purer materials melt at higher melting points and over narrower ranges of about 1 to 2 degrees than contaminated compounds. The capillary method is one technique to determine melting point range. This method operates by placing a solid sample at the bottom of a capillary tube, then slowly heating the tube and recording the melting point range of the investigated sample. To get an accurate melting point range, you have to heat the sample at an extremely slow rate at around 1 to 2 degrees Celsius per minute. The slower the better. However, some solids have high melting points and it will take forever for the sample to melt. To solve this, we have something called plateau temperature. A plateau temperature is generally set at 5 to 10 degrees Celsius below the expected melting point. For example, if your sample's theoretical melting point range is 85 to 87 degrees Celsius, then the plateau temperature will be placed at 80 degrees Celsius. Or if the expected melting point range is 132 to 134 degrees Celsius, the plateau will be set at 127 degrees Celsius. So what can you do with this? You can heat the material quickly to the plateau temperature, which will substantially reduce the waiting time. Then, at the plateau temperature, you can heat up at a significantly slower rate at around 1 to 2 degrees Celsius per minute to obtain an accurate reading of the melting point range. Our lab uses the Stewart apparatus to measure a sample's melting point range. Here, we will show you the steps of taking the melting point range of a known sample using this apparatus. Step 1, we need to pack the sample. We will start by obtaining a glass capillary tube with a diameter of about 1 millimeter. Gently tap the open end of the capillary tube on the solid sample to introduce some solid into the capillary. Then, invert the capillary, hold it near the bottom, and tap it on a flat surface so the solid drops to the bottom of the capillary. A sample height of 2 to 3 millimeters should be sufficient to measure the melting point. If the sample height is less than 2 millimeters, you can repeat the previous steps to introduce enough solid into the capillary tube. Once you place enough sample in the capillary, obtain a long piece of straight tube around 1 meter, keep it standing vertically on the bench top, and drop the capillary tube into the long tube. When you let go of the capillary, it will fall down and bounce a few times inside the tube. This helps push and pack the sample at the bottom of the capillary tube. You can repeat this step as many times as you need. Usually 3 to 4 times are enough to pack the sample nicely at the bottom. Observe to confirm. Once done preparing the sample, turn on the light of the apparatus and place the capillary tube into the sample chamber. Insert the tube into the side of the heating block via the holes provided. You can insert from either side of the block. Look down the magnifier and position the viewing tube so that the sample can be observed clearly. The BioCody apparatus can hold up to 4 capillary tubes at the same time. That's why you see 2 holes from either side. However, you usually only need 1, so you can place the tube into either hole from either side. Step 2. Set the plateau temperature. As said above, the plateau temperature should be 5 to 10 degrees Celsius below the expected temperature. To set the plateau, press and hold the plateau set button. The plateau light will flash, and the display will now show the current plateau temperature. If you need to change the displayed plateau temperature, while continuing holding down the plateau set button, press the arrow keys up or down to adjust. Then release the plateau set button. The new plateau temperature is now set and all function lights will go out. After that, press the start key. The apparatus will quickly heat up to the plateau temperature. You will see the heating light lights up. If you need to recheck the plateau temperature during operation, you can do so by simply pressing and holding the plateau set button. This action will not interfere with the operation of the apparatus. Step 3. Heat up your sample very slowly. After the apparatus reaches the plateau temperature, it will stop heating. You will have to press the start button again. Otherwise, the apparatus will just stop at the plateau temperature. Now the apparatus will start heating at a much slower rate, around 2 degrees Celsius per minute. The ramping light will be lit up as well. Step 4. Observe and record the melting point range. You will need to observe your sample carefully from the viewing tube. Record the temperature at which the solid just begins to melt, as well as the temperature of complete liquefaction. Don't take the capillary tube out when measuring the melting point, because once the tube is out in the air, the sample cannot be reused. You must always record and report the melting point as a range. Since your sample may be still wet when you place it in the capillary tube, your recorded melting point can be lower than the theoretical value. After the melt has occurred completely, press the stop button. All function lights will go out and the apparatus will cool down slowly to room temperature. If you want to continue using the apparatus for another trial, you should let the apparatus cool down properly. Once it cools down, you can restart the process. Remember, don't insert a fresh capillary tube into a hot heating block. This can cause the displaying temperature to deviate from the actual temperature of the sample. What you should do is let the apparatus cool down to at least 30 degrees Celsius below the melting point, then insert the tube. Reminder: in your report, you must always report the melting point as a range, along with the information of the instrument you used, which includes the name, model number, and the manufacturer. We can set up the plateau temperature if we have at least a general idea of what our sample is. However, what if it is a new compound and we don't know its theoretical melting point range? We have a special strategy to solve this problem. If you have a new compound and you couldn't figure out the expected melting point range, you will first set the plateau at a ridiculously high temperature at 200 degrees Celsius, for example. This allows the apparatus to ramp up to 200 degrees Celsius at a rapid rate. At some points during this process, the sample will melt. Though you cannot obtain an accurate reading since the heating rate is too fast, you at least have a rough idea of what the sample's melting point is. Once the melting occurs, you can stop the operation by pressing the stop button. Now you can start over and set the plateau at 5 to 10 degrees Celsius below the predetermined rough melting point. Here, when the plateau is reached, don't forget to press start so the apparatus will heat up slowly to the expected melting point. Make sure you press the stop button and cool the apparatus down properly before running a new measurement. Here's an example. This is a new compound and we don't know its expected melting point range. In the first trial, we set the plateau at 200 degrees Celsius. While the apparatus is heating up to 200 degrees Celsius, we observe the melting process from the viewing tube carefully and find that the sample melts roughly at 145 degrees Celsius. After the apparatus is cooled down, we can start another run. For the second trial, we get a new, fresh solid sample in a capillary tube. Place the tube in the heating block. This time, the plateau is set at 140 degrees Celsius, which is 5 degrees below the rough melting point. Here, when the apparatus reaches the plateau, we press the start button so the apparatus can begin heating up slowly until we obtain an accurate reading of the melting point range. As the final step, we report the melting point range with the manufacturer and the model number of the instrument we used. You can even repeat the process to make sure that the melting point range you obtain is accurate and reproducible. And that is how you determine the melting point range of a compound.